Hi everybody, welcome back to the Feynman technique. This is going to be my 100th example of Feynman integration on this channel, and also this is going to be the last video for this channel. This channel was really just kind of a trial run for making a mathematics YouTube channel. My next channel, I haven't even decided on a name yet, but it's going to be the exact same thing, just it's going to be more professional. The videos are going to be of a higher quality. But anyway, let's just get right into... Oh, and I'll continue to post updates on my book on this channel. So any of you interested in following along with that, just check back regularly. Check back on my posts, and I post frequent updates for new drafts of the book. But anyway, this is the integral we'll be solving today. I got that this integral from the channel Maths 505. We'll be using these tools. This is Catalan's constant, usually denoted G, and it's equal to this sum right here. And we'll also be using the fact that the alternating sum of the reciprocals of the squares is equal to pi squared over 12. And right away you can see I broke this integral up using partial fraction decomposition. And none of you should have any trouble with that, so I just skipped right to it. So if I is equal to this, then it's also equal to the sum of these three integrals right here. All right, so now let's create two functions of t. We'll create f of t, which is going to be equal to the integral from 0 to 1 of, we'll say, x to the t over x squared plus 1 dx. And right away, I'm going to show how this can be represented as a sum. I've done this many times on this channel, so I'm just going to jump right to what the answer is going to be. This is going to give us the sum, as n goes from 0 to infinity, of -1 to the n over 2n plus t plus 1. All right. Now let's create a function. Well, actually, let's find f prime of t. So using the Leibniz rule, we'll take a partial with respect to t of the integrand, giving us the integral from 0 to 1 of x to the t natural log x over x squared plus 1 dx. And that's going to be equal to the derivative with respect to t of this, which is going to give us negative sum, as n goes from 0 to infinity, of -1 to the n over 2n plus t plus 1 all squared. All right, so there's f of t, there's f prime of t, written in both integral and summation notations. Now let's make another function of t. We'll call this one g. So g of t is going to be equal to the integral from 0 to 1 of x to the t over x plus 1 dx, which is going to be equal to negative sum, as n goes from 0 to infinity, of -1 to the n over n plus t plus 1. Yeah, and then, oh, I'm sorry, no, there's no negative there. And then our g prime of t will be equal to the integral from 0 to 1 of x to the t times the natural log of x over x plus 1 dx, which in turn is going to be equal to the derivative with respect to t of this, which will give us negative sum going from 0 to infinity of -1 to the n over n plus t plus 1 all squared. All right, great. Now we have the pieces. So let's just write down I in terms of these pieces. Let's see, I is going to be equal to 1/2. All right, we need to recover this. Well, that can be recovered by plugging in t is equal to 1 into our f prime of t. You see right here, this is our f prime of t. If we plug in t is equal to 1, we'll just recover that x. And we'd recover this entire thing minus, with the exclusion of this 1/2. So we can say that I is equal to 1/2 of our f prime evaluated at the point t is equal to 1 plus 1/2 of our f prime at the point t is equal to 0, because x to the 0 is 1. And then minus 1/2 of our g prime evaluated at the point, let's see, g prime of t, we would want that at the point 0. All right. So now let's kind of consolidate everything we have. All right. We don't even care about f of t. We don't care about g of t. Only interested in the derivatives. All right, so there's f prime and g prime. So let's just write them both here. Let's see. F prime of t is equal to negative sum, as n goes from 0 to infinity, of -1 to the n over 2n plus t plus 1 all squared, and our g prime of t is equal to negative sum, going from 0 to infinity, of -1 to the n over n plus t plus 1 squared. Now we don't need this. All right, but we know that I is equal to 1/2 of this at 1 plus 1/2 of this at 0 minus 1/2 of this at 0. So let's just write that down. All right, that's going to give us I equal to 1/2 the sum. Let's see, we're taking f prime at 1 right now. So it's actually going to be negative this thing evaluated at the point t is equal to 1. So that's going to be the sum going from 0 to infinity of -1 to the n over 2n plus 2. Right, okay, and then we'll have plus a minus. So minus 1/2 the sum as n goes from 0 to infinity of this thing at the point t is equal to 0. So that's -1 to the n over 2n plus 1 squared. Aha, see, this is just 1/2 Catalan's constant. So what we're actually going to do is just write minus 1/2 g. And then we also have minus 1/2 g prime at 0, which would be minus, which is going to be a plus, the sum, as n equals 0 to infinity of -1 to the n over n plus 1 all squared. Now you'll recognize that this exactly matches this, which is pi squared over 12. But we won't take care of that just yet because, I forgot this squared here. My apologies. Okay, we can factor out a 1/4 by making this an n plus 1. And then this will become minus 1/8. So now we have two identical expressions. Well, identical except for the fact, there should be a 1/2 here too. Making all sorts of mistakes. Okay, yeah, because that's minus, which is a plus, and then 1/2 this evaluated at the point 0. Okay, so I don't believe there's any more mistakes here up on the board. So let's just continue. All right. Well, let's see. We have a minus 1/8 of something and then plus 1/2 of something. So that's going to be plus 3/8 of that thing. Plus 3/8 of that thing. All right. So there we are. Let's just finish this up really quick. We can say that I is going to be equal to, well, let's see, we have this 3/8 times this thing, which we know is pi squared over 12. So that's going to give us pi squared over 32. Right? Because that 3 will reduce to a 1, reducing this to a 4, and then we'll just have 1 over 4 times 8, which is 32, yeah. All right, so that's pi squared over 32 minus 1/2 Catalan's constant g. And that is the answer, and I hope you enjoyed that. And, well, you know, thanks for being a part of this channel. Like I said at the beginning of this video, this channel is going to be coming to an end. I will still be creating content on YouTube. I'll post updates when I, decide on a, basically when I have the first video on that channel up and running. I will let everybody know on this channel, so you guys can switch over to that one. All right, well, we'll see you guys over on the next channel, and hope you enjoyed that.